Hey, what's up? It's your old pal, Mr. Cook. Let's see what we're doing in this one. So we're doing the AP Calculus AB Spring Final Exam Review. We went through the first 29 problems. We just got 10 more to go, I think, something like that, 10 or 11 more. And we've already gone through like the majority of this stuff, like conceptually. So really, we're just doing like additional examples of the same kind of problems, I think. So let's see here. So we'll start at 30, go through the 6 problems, I guess, on this page. 1, 2, 3, 4, 5, 6. Yeah. And then we'll set up for the last video. Okay, so dy over dx is equal to that. Find the intervals where y is increasing at an increasing rate. So if it's increasing at an increasing rate, that means that it'll go like this. So like increasing means it's going up and to the right? But then at an increasing rate means that it's getting more and more like vertical. So that means that it's going to be concave up and positive. So it's looking for both of these things. Where y is increasing, that's where dy dx is greater than 0. And then at an increasing rate means that the second derivative, d squared y dx squared, is also greater than 0. So we need to find both of these things. So the first one's going to be easy. It's increasing. Where is it going to be increasing? Where whatever x values we get where we have a positive derivative here. So I'm going to first solve for where this is equal to 0. That's pretty easy because it's already factored. So I just find the x values where it's where it's 0. So for this one, I get x is equal to negative 5/3. For this one, I get x is equal to 3. So I make my little number line. Negative 5/3, 3. And then this splits it up into 3 intervals, negative 5/3, negative infinity to negative 5/3, negative 5/3 to 3, and then finally 3 to infinity. And this is for where the function y is increasing. Okay, so let's get some test points, and then we'll plug it into the derivative. So we're going to plug it in over here and see if we get a positive number or a negative number. So let's pick a number that's less than negative 5/3, like maybe negative 3. I don't know. So if I plug in negative 3 into here, let's see, I get negative 9 plus 5, which is a negative number. Then negative 3 minus 3 is going to be a negative number as well. So if I get two negatives multiplied together, that makes positive. So this is where it's going to be increasing. So positive first derivative. So far, like that's an interval over here. All right, now let's take a look at a number in this interval. So we're going to go from negative 5/3 to 3. Let's pick 0, I guess. If I plug in 0, 0 plus 5 is 5, which is positive. 0 minus 3 is negative. A negative times a positive is a negative. This is decreasing, so this interval is not what we're talking about in this description. And then going from 3 to infinity, let's pick like 4, I guess. I don't know. So 4 times 3 is 12. 12 plus 5 is obviously a positive number. And then let's see, 4 minus 3 is a positive number as well. So positive times a positive is a positive. So this is also increasing here. Okay, now let's take the second derivative and see where everything overlaps. Okay, so if I want to take the second derivative, I don't want to do the product rule. I'm just going to distribute this out and then take its derivative. So if I distribute all this stuff in here, like FOIL it or whatever, right? I get 3x squared, and then I get, let's see here, 5x, and then minus 9x, so that'd be negative 4x, and then minus 15. Let me double check that real quick. So I get 3x squared. I did too much of that in my head. And then minus 9x, and plus 5x, and minus 15. Yeah, that's right. Okay. All right, now let's take the derivative of this thing. So if I take the derivative, now I'm going to get the second derivative, d squared y over dx squared. So that'd be 6x minus 4. And then this one, it'll factor. So if I factor out a 2, I get 3x minus 2. So that means that my lone, critical number would be x is equal to 2/3. All right, so now for 2/3, let's see here. So I got a number line over here. This is for the second derivative. So 2/3, and so I've got two intervals, negative infinity to 2/3, and then 2/3 to positive infinity. And then I just pick some points, plug them into the second derivative, which is like this guy over here. And then and let me make that look more like a 3. There we go. And then, I still got to just see if it's going to be concave up or concave down. So I'm looking for concave up and increasing. Okay, so this will tell me where it's concave up in this interval. So let's pick a number between negative infinity and 2. How about 0? So if I plug in 0 to this, I get 2 times 0 minus 2, which is negative, and 2 times the negative number is a negative number. So this is going to be concave down in this interval. And if we pick a number more than 2/3, like maybe 1 or something like that, we get 2, and then 3 minus 2 is going to be a positive 1, and 2 times the positive number is positive. So we're going to have concave up over here. Okay, so now I'm going to like overlap this stuff in here. Okay, so like I know that, let me do some color changes here. I've got increasing from here on. Okay, so that's like what we want, increasing. And I've also got increasing from here on. Okay. And then I've got decreasing in here, okay? Like in this interval. Now if I overlay this interval over here, so I'm just looking for 2/3 and above because now it's concave up, okay? So 2/3 would be like right here-ish, right, 2/3. And then that means that everything to the right of that is going to be concave up. So that means that the only place where it's going to be both increasing, so green, and also second derivative positive, so in other words, concave up, is going to be in this interval right here. So that's going to be the interval that I'm interested in, 3, infinity. That's the one that we're talking about in number 30. Okay, so next, find the area of the region enclosed by the graphs of negative x squared plus 6 and 2x minus 5 and round to 3 decimal places. That means that we're going to have to use a calculator probably. So let's see here. If I graph it out on my calculator, it'll look something like this. So y equals negative x squared plus 6. So that means it would start at 6 and then it'd go downwards like that. There's my parabola. And then this is just a line and it starts at negative 5. So like maybe negative 5 is right there. And then it'll go up to, so it's like that kind of. So what I'd have to do is find the intersection points here and here. So find the area of the region enclosed by the graphs. All right, I got to find, so to find the area, right, it's going to be, it'll start at this intersection point from x, like right there, and then it'll go all the way to this intersection point at x. And then it's going to be the top function minus the bottom function. The top function clearly is that parabola. So we could go negative x squared plus 6, that's my top function, minus my bottom function, which is this linear equation, and then dx. And then I just got to find those intersection points. So, you can use your calculator on that. It's nothing terrible. All right, let's see. So negative x squared plus 6. And then the other one is 2x minus 5. And then I've got to find the zeros on it. Find the intersection points on it. So I use my calculator here. I better zoom out too. It doesn't look like I'm going to see the intersection points. I still don't see both of them, darn it. I'll zoom out just a little bit. Or no, I'll just change the window. Go to negative, 20 or something. I just need to have the intersection points visible. There we go. So now calculate, go to intersection points, 5, and then just kind of, find those intersection points. Use your calculator like we've done a million times. So one of them is going to be at 2.4641. So that's like the one that's far right. So 2.4641. And then the beginning is the left intersection point. So we find that one next. And just, Okay, I'd say it's like right there-ish. So negative 4.4641. Okay, and then calculator time, and then, round to 3 decimal places. So that's number 31. I'll let you do that. Just use math 9 at this point. Find the volume of the solid formed by revolving the bounded region of y equals square root of x. And then x equals 0, y equals 3 around the y-axis. Okay, so graph it out. Got our square root function here. And then x equals 0 is the y-axis. And then line y equals 3 is like up here. So let's say it just like stops right there. Okay, so that's y equals 3. And then that would intersect at x equals 9 right there. Okay, so let's see. You can either do disk method or shell method, because if this thing is rotated around the y-axis, it'll look like this. So here's the original graph. And then it'll reflect over the y-axis, so it'll reflect over its axis of rotation, so like that. And then like kind of circle around like that. So it kind of like looks like a cone, but it's like a curved cone, if you will. So you can either do the disk method or shell method on this. I think either like both kind of equally challenging, I guess. Maybe a slight edge to the disk method, just because like all you have to do is just solve for the different variable. So yeah, let's do disk methods first. So volume is equal to integral. And then since rotating around a vertical axis, the y-axis, I know it's going to be in terms of dy. So that means I need to change this equation in terms of y. So solve for x. X is equal to y squared. Okay, and then next. Along the y-axis, we start at 0 and we go up to 3. So the bounds are going to go from 0 to 3. And disk method goes like this. It's pi times something squared, and then, dy or dx or whatever. Okay, and then what we do is we just go up along the y-axis and stop at like one of the y values in between our bounds, 0 and 3. And then just like go directly to the function, wherever the graph is or whatever makes up the meat of the three-dimensional object. And then just like, see where that slice is going to be. It looks like the slice for the radius, right, is just going to be based on the function. So this is going to be a real easy one. It's just going to be y squared. So there you go. There's disk method. I'm not even going to do shell method because shell method would be a little bit convoluted at this point. Just use disk method for this. And then plug it in your calculator, round to 3 decimal places, and you got number 32. The graph of piecewise linear function, f, is shown below. If g is defined by the function g of x equal to this, well, this looks like fundamental theorem of calculus again. I'm just plugging stuff in. So like g of 5, plug it in, I get 5, 1, and then f of t dt. So this tells me that I'm looking for the area under the curve of the f function from 1 to 5. So I start at 1. I go all the way over to 5, and I find that area. So this area is just going to be a triangle, and it's going to be negative because it's below the x-axis. So I have a base of 2 and a height of 2, so 1/2 of 2 times 2, and it's going to be negative. So might as well just write it over here, negative 1/2, 2 times 2. And then after that, it looks like I got another triangle here. So that's going to have a base of 1 and a height of 2, so it's going to be a positive 1/2 of 1 times 2. And then I got a rectangle over here. And the rectangle is going to be a positive number because it's above the x-axis. And then it's just going to be the base, which is 1, times the height, which is 2. So 1 times 2. So let's see. Let's add all this stuff up. So I get negative 1/2 times 2 times 2, which is just negative 2. And then 1/2 of 1 times 2 is going to be 1. And then 2 times 1 is 2. So it looks like you just get negative 1 for the first one. Okay, and then next one, I've got to find g of negative 1. So this one's like, I don't know, a little bit tricky, I guess, because it starts at 1, right? So this is going to go from 1 to negative 1, and then f of t dt. So first thing that I would do is just like change the bounds, because you notice that the bounds are a little bit weird here. So I got to find the area from those. Well, I mean, I don't know. It actually kind of depends on how you look at it. Maybe this would be like easier for some of you guys. I'm not sure. But no, let's do it as is. All right, so I go from, it changes to a negative, okay? And then I'm just going to change the bounds, because if you make that negative out front, it changes this number and this number, like swaps them. So I can make that a 1 and this a negative 1. And this is a little bit more like sensible, because this is just saying, hey, find the area from negative 1 to 1, right? And then you just got to remember to put a negative in front of it afterwards because of the boundary switch. Okay, so let's find that area. Let's start at negative 1 and go all the way up to 1. So it looks like it's just going to be like 2 shapes. So you have a triangle and then also a rectangle. So I'm just going to add those 2 together. So I've got a negative because of this, okay? And then my 2 little areas, they're both going to be negative. So I've got a triangle. So it has a base of 1 and a height of 2. So 1/2 of 1 times 2. And since it's below the x-axis, it's also going to be negative. And then let's see here. Then I've got this rectangle. It's got a base of 1 and a height of 2. So 1 times 2. and it's also going to be negative because it's in front of the or below the x-axis. Okay, now let's just keep track of all these negatives. Be careful. So 1 times 2 is 2. 2 divided by 2 is 1, so I have negative 1 from this first part. And then 1 times 2 is 2, and it's negative. So negative 1 and negative 2 makes a negative 3. And then I've got another negative out front, so that makes this a positive 3. So the area for this one's going to be 3. Okay. Last couple problems on this video. 34. Find the average value of the function f of x is equal to 1 over x over that interval. Average value of a function is just a formula. Average value looks like this. It's 1 over b minus a, and then from the integral from a to b of f of x dx. Okay, so just plug that stuff in. So the function that we're talking about is 1 over 2x. And then the bound is the interval, 1 to 4. So 1 is A, 4 is B. And then just let your calculator do the rest. So math 9, this one. Use the u substitution to write the integral dx in terms of u with new limits of integration. Yeah, so this is a u sub because if I take the derivative of x squared plus 1, then I get du is equal to 2x dx. And you can see I've got an x right over there. So this is going to substitute out really nicely. Okay, so let's go ahead and do our due diligence for this thing. So I've got 0 to 1, x, and then x squared plus 1 to the third power, dx. So let's start swapping some stuff out. So this becomes a u for our substitution. So u. And then let's see here. Now let's change out the dx. So if I divide both sides by 2x, and I get dx is equal to du over 2x. And then the x here and the x here will cancel out or divide out. Now let's move that 1/2 out front too. All right, now the last thing that I need to change is just the bounds, and the bounds are easy. These are x values right now, 1 and 0, so I need to change them to u values. So all I have to do is just take this equation here and plug in the x values to get the u values. So let's start with u. So start with 0, I'm sorry. So u is going to be equal to 0 squared plus 1. 0 squared is 0, 0 plus 1 is 1. So that corresponding u value would be 1. So I'm going to write a 1 in there. Now this x value of 1, I'm going to also plug that into the equation. So u is equal to 1 squared plus 1, which is 2. So that means that one's going to change to a 2. And there we go. There's our integral rewritten in terms of u. All right, so there's 30 through 35 on this page, so page 7. Now we're in the home stretch, 36, 37, 38, 39, and 40. So last 5 problems, and that'll be on the next video. Okay, so I hope you found this video helpful. If you didn't, go find your math teacher, get some help from them. If you need help from me, I'm Mr. Cook. I'm always here to help you out. Just find me in the morning or after school, and I'll do what I can to help you out. Okay, thank you very much. I'll see you on the last video. All right, bye-bye.